Well, hello. We're going to do some multiplying of binomials today. Our main objective is to multiply two binomials or a binomial by a trinomial. One of the most popular methods that are used today, there's a couple different ways to do this, but one of the most common ones is using FOIL and using that as a reminder on how to distribute everything of all those terms to all of these terms. So it is one big multiplication process. So instead of just like a normal thing, where we're distributing one term out. This time we are distributing two terms out to two different terms. So we have to distribute it to the entire piece. So let's look at the first one. So, and part of our FOIL, the first element that we do is we take our first part and we multiply it by the first of the second expression. So that is 5x times 2x. The second part of FOIL is the O, which is outer. So we're going to take our 5x times the outer end, which is the 1. So that's why we have 5x times 1. And then we're going to take our I, which is the inner. And that's where we take our negative 3 times our 2x. So we're distributing out that negative 3. And then my final one is my last, which is my negative 3 times my 1. So I can see that I've distributed out the 5x and I've distributed out the negative 3 to both terms, the 2x and the 1, the 2x and the 1, and we use FOIL to kind of organize that. We simplify the terms. 5x times 2x is 10x squared. 5x times 1 is 5x. Negative 3 times 2x is negative 6x. And then we have negative 3 times 1 is negative 3, keeping track of those negatives. And then my last part is to rearrange the order and combining like terms. So that's why my product is 10x squared. And I take both of my x terms and I combine them and end up with negative x left over minus 3. And here is my product. All right, why don't you press pause, and I'm going to have you try these ones right here. All right, let's see how you did on this one. For 3a, I distribute out all the terms using FOIL first, the outside, the inside, and the last terms. The first term I did the inside greens just so I can identify my common terms, simplified everything, and I wrote it with my highest degree first, so 3x squared. The second one, I got this, just keeping track of my negatives. My last one, I end up with 4 terms on this one, but keeping an order of my highest degree first, degree being 3, 2, 1, 0. There's another way to also multiply trinomials and binomials. You can do it by arranging them vertically. So let's give that a try, because then you can choose how you want to do that. So I'll take my first one, which would be 3x squared plus x minus 5, and I set it pretty much just like a multiplication problem. 2x minus 7. And now I'm just going to do like I would do for a multiplication problem. I would take my negative 7 times my negative 5, and I get 35. I take my negative 7 times x, and I get negative 7x. And I take my negative 7 times 3x squared, and I get negative 21x squared. I want to get a plus in here. Then I skip a term like I would normally do when I'm multiplying, and I would, when I'm looking at like the tens place, 2x times negative 5 is negative 10x. 2x times x is 2x squared. And then my last term is the 2x times 3x squared would be 6x squared. Plus there. And I bring all of these together. And this is where I can just add them or combine like terms. Negative 7x plus negative 10x is negative 17x. And then I've got my negative 21x squared plus 2x squared. I'm going to end up with negative 19x squared. And I have 6x squared. So this ended up being, there we go. Hold on, we got something fishy here. I missed something. Here it is. the 2 and the 1. So this is a 3 and that's a 3. There we go. All right, why don't you give it a try? And like you saw from my example here, keeping track with the exponents, keeping track of your negatives. So press pause. Why don't you try arranging your polynomials vertically and multiplying that way to see if you prefer that method. All right, let's see how you did. I ended up with 4 terms in this one. And I, again, aligned them up based upon the highest degree of being 3. This is a 3rd degree equation here. So for the reasoning that we're looking at, how can you use the distributive property to find the product of a trinomial? You could really distribute out each piece. Really, you can look and distribute out to each term. That's really how you would do this. So there would be 1, distribute out to each term, distribute out to each term. So it's like a super foil, super duper foil. All right. Speaking of foil, I'm going to go and drink some chocolate milk. I'm using like 47 straws.